Hello students, welcome to Chaitanya Educational Institution IIT Academy. Today I will be discussing you the latest mains paper that held on 2nd September morning shift. First of all, let me clear you certain things that these questions are based upon the memory of our students. So there might be an error in here and there. So we will be posting the solutions very shortly, the final solutions. Now without delay, we will move into the analysis of the paper, but before that this will be very helpful for the aspirants of 2020, right, as well as aspirants of 2021. So please note and follow the analysis. Let me quickly get into the topics. The first question that you see here in front of you is which metal is used in the devising of photochemical cell. Now for this matter, the criteria here is that ionization energy has to be low, right? Ionization energy has to be low, and when you see here lithium, sodium, and you move down to cesium, and we know that ionization energy decreases down the group. So therefore this particular fellow is having the lowest IE, and that makes it suitable to use it in a photochemical cell. So therefore the answer is 4. This question was from the periodic properties, or you can also consider it to be the S block, and very basic question. Now let's move on to the next question. So here this question is from the gaseous state, and they are asking about, you can see a container is there and there are 3 moles of O2, 5 moles of AR, and we need to find out the sum of the internal energy in terms of R, which is a gas constant, and T, which is the temperature in absolute scale. Now what is the formula, people? Formula is F by 2 nRT. Now we are going to write down U total, right, and this will be internal energy of oxygen gas plus internal energy of argon gas. Now for oxygen, which is a diatomic molecule, the degree of freedom F is what? F is the degree of freedom, and it depends upon the atomicity of the gas. Oxygen, which is a diatomic molecule, the degree of freedom is 5 by 2. What is the moles given? 3 moles. So we will put here 3 and R and T plus the internal energy of argon, which will be again F by 2 nRT. What is the degree of freedom for argon, which is a monoatomic gas? Now it will be 3 and that is 2. How many moles are given here? 5 moles is given here, so we'll put a 5 here, we'll put R, we'll put T, and that's it. Now if you work it on, and you will get the answer 15 RT. So let's move on to the next question. Now the next question here you can see is from again periodic properties, again a very basic question. You must be knowing the trends. They are asking which property trend, and they are asking the magnitude. Please mind the keyword magnitude is different from the other across a period. So it is very easy and very basic. Atomic radius, what does it do? I'm writing along a period, that is from left to right, that is along a period. Left to right, what happens for atomic radius? It decreases. What happens for electronegativity? It increases. What happens for electron gain enthalpy? The magnitude increases. What happens for ionization energy? This also increases. So as you can see, 3 properties that increase and 1 property decrease. So that makes my answer the first one. So quickly we will move on to the next question. Now next question here you can see is from surface chemistry, again a very important and very popular topic. This is based upon adsorption isotherm, and here the popular isotherm that has been asked is Freundlich isotherm. So if you know the relationship here, that is adsorption will be equal to some constant times multiplied by the pressure raised to power 1 upon n. Now here n is some integer 1, 2, 3 like that. Now if you take a logarithm in both sides, you are going to get this particular relation. Now as you can clearly see, we have given a relationship here, the log x upon m, that is this one, versus log p, which is this one. Now if you compare this one like this to be y, and if I take this to be x, then this one will become m, that is the slope, while this one will become the c intercept, that is the y intercept, that is the c. Now as we can see from here, the y intercept is given, right? That means the value of this particular thing is given, which is equal to 0.477. Now if you apply the mathematics, then you can get clearly k is equal to 3 by using this particular relationship. Now if k is equal to 3, what is the slope? They are saying the slope is equal to 2. So that means what? 1 upon n, the value is given as 2. Now what they are asking? They are asking, find this particular value when the pressure is equal to 4, when the pressure is equal to 4. So that means we will use this equation and we will put the values there. So x upon m will be equal to k. Now what is k? K is 3 multiplied by the pressure. What is pressure? Pressure is 4 and raised to the power 1 by n. Now what is 1 by n? 1 by n is 2. So 4 square makes it 16, and 16 into 3 will give you 48. So as a result, we are going to get this particular answer. Now quickly move on to the next question, that is question number 5. Now this is from chemical bonding, that is from vesiper hybridization part. Now here option number 1 and option number 3, you can clearly, not 3, my mistake. Option number 1 and option number 2, you can clearly strike it off. Why? Because in the question they are saying polar, right? Because these geometry are symmetrical, and when the geometry is symmetrical, overall dipole moment, that is net dipole moment, becomes equal to 0, so they cannot be polar. Now we are left with two options, that is either 3 or 4. This is the elimination technique, people. This way you can do problems with a very ease and comfortability, and you can reduce your chances of error. Now among the two options, even if I select one, the probability is 50%. Now keeping that in mind, I will again reject this particular option, because this square pyramidal kind of geometry will only come when you have a hybridization of sp3d2 with one lone pair. Now if the hybridization is sp3d2 and there is one lone pair, that makes what? There should be 5 bonds, there should be 5 sigma bonds, but in this particular compound there is no 5 bonds, there is only 4 bonds, as the surrounding atoms are 4. So which makes me only this option is left for me. So therefore the answer is this. Now if I go into detail, please see the geometry of seesaw. Seesaw geometry will be when we have a hybridization sp3d, and it will result in a TBP geometry, which is something like this. Now in this geometry, if I put a lone pair here and remaining 4 atoms, considering this to be my A and these all B atoms here. Now if I say that I need to tell the shape, I will not consider this lone pair, and if I not consider this lone pair, the entire system will look like a seesaw. If you look it in a sidewise angle, there is A in between, B at the other ends, and 2B placed this way. So this clearly resembles a seesaw. This clearly resembles a seesaw, and in this particular case it is the unsymmetrical hybridization. So therefore the dipole moment will not be cancelled out, and you will get a net dipole moment which is not equal to 0, and we will say it is a polar compound. So therefore the answer is 3. So quickly move on to the next question. Now next question is again from this environmental chemistry part, and this is nowadays becoming popular with this NEET and mains as well as. So you have to keep into mind these two chapters, particularly your environmental chemistry and chemistry in everyday life. So now let us move into the question. They are asking the incorrect statement. Please mind the keyword, the incorrect statement. So first statement, you know it is correct because it protects us, right? So if it protects us, it acts as a shield. So fourth is also correct. So I am left with only 2. Now if I select out of any 2, my chances are 50% to be correct. So this is a guesswork, not a guesswork, but a calculative guess. You go by elimination, you eliminate as much as possible and then you make a calculative guess if you don't know. But here, let us see the detail, what is the chemistry with the ozone. Now what happens when NO reacts with ozone, you get NO2. So they are saying this, so this is true. So that means what? This is my incorrect option and the question is asking incorrect, so my answer is 3. I will tell you the correct thing. When Cl radical reacts with O3, you get chlorine monoxide and here they have written chlorine dioxide, which makes it incorrect. So next we move on to the next question. Next question is again from gaseous state and a little bit of thermodynamics. So again they are asking incorrect, so please mind the keyword, that is incorrect, and they are asking for an ideal gas, and for ideal gas we know PV is equal to nRT. Now people, let us do a little bit of math on it. If I change the V, that is I take the V to the right hand side and I multiply both sides by the molar mass. This capital M is molar mass. Now molar mass multiplied by N, this is what? This is mass. Mass divided by volume, this is what? Mass divided by volume, this is what? Density. So now we have here PM is equal to dRT. PM is equal to dRT. If I put D on one axis and T on one axis, then I can get what? D into T, that is equal to PM upon R. Now this thing is constant. If I assume the pressure to be constant, this thing is constant. So x into y is equal to constant. What is the graph? Rectangular hyperbola. So this is correct. Now if I see properly, then again I work on this. This D will be equal to PM by R, which is a constant multiplied by 1 upon T. Now if this is x and this is y, I am going to obtain a straight line, which is my option 2. So this is also correct, which makes it what? This option incorrect. Now as you can see clearly, D and T are having this particular relationship, so this cannot be the graph. So this is my answer for question number 7. So next question is we have from surface chemistry, and again this colloid part is very important. Please go through it for your other mains paper. I am sure questions will be coming from this part, but this question is very informative. Now it is totally based on memory, right? So they are asking a solid sol. So please go through the classification of solid. That means the dispersion medium and the dispersion phase both has to be solid. Both has to be solid. Then only we call it a solid sol. Then only we call it a solid sol. So here the answer is gemstone. Here the answer is gemstone. So please go through it. And next question please. Now in this next question, it is from electrochemistry, right? So if you see through this equation, which is a redox reaction, okay, and then we have the concentrations 1 molar. So what makes it? It makes it the standard condition. So it makes the thing easier for us, right? We can simply write down the E naught cell because it is given in the standard format, and this E naught cell will be simply equal to E naught oxidation plus E naught reduction. Now you see this equation, which fellow is getting oxidized? This particular ion is getting oxidized, right? So what is the oxidation potential of copper? Here you see the reduction potential is given. So when you write the oxidation potential, you put a minus in front of it, that is 3.34 volt plus E naught reduction. Now which fellow is getting reduced? This fellow is getting reduced. So you check here, the reduction potential is given to you as minus 0.6. So that is minus 0.16 volt. Now when you add it up, you are going to get minus 0.50 volt. Now in the question they are asking Gibbs energy change. Now how can you write down the Gibbs energy change? Delta G naught is equal to N E naught F. They are asking for the cell, you put here cell. Now this particular value you put it here, right? You write down the value of F, that is 6500. And what is N? N is people 2, because here when it is oxidized 2 electrons are released, and when it is reduced 2 electrons are gained. So the value of N is 2. You put the value here, you will get the answer for this particular question. Next question is from again chemistry in everyday life, and here they are asking simply another informative question, the formula of Dettol. The formula of Dettol, that is basically you draw a phenol, right? You draw a phenol, on the para position you put a chlorine, and with respect to the phenol the meta positions will be having CH3. So this is basically the chemical structure of Dettol, and we can see in the options this is that particular option, so my answer is 3. So next question is again from organic chemistry, and here they are asking nomenclature, which is a very kind of a rare thing. I guess you people are lucky. Now in this particular question, what they really want to ask you is the selection of main chain. Now how main chain is selected, there are some priority. First, senior functional group has to be there. Senior functional group has to be there. The out of this particular fellow and this particular fellow, this is my senior. This is my senior. So I will take this particular functional group in my main chain. So I need to include the senior most functional group into my main chain. What is the second thing that I need to have? The second thing is that maximum unsaturation. That means pi bonds, maximum unsaturation. So that means I need to include this pi bond into my main chain. Then what do I have? The third priority area. The third priority area is more number of carbons. More number of carbon atoms. So if you include this, and then fourth criteria is the maximum substituents, So if I want to have this criteria there, okay, functional group is done, maximum unsaturation covered, then I need to cover more number of carbons. So how can I cover more number of carbons? Starting from this fellow, this is 1, this is 2, this is 3, this is 4, and this is 5. Now I have an option of selecting this particular S6 or this particular, this is also carbon, this particular S6. Now if I select this one as 6th, then this makes this one a substituent. Then I will call these substituents by the name of formyl. Now if I include this one here, into my main chain, then this is my substituent as well as this is my substituent. So if I go through it very, very clearly, then I am drawing here again for your comfortness. So if I consider this to be a substituent and this one as substituent, then my main chain includes how many carbons? 1, 2, 3, 4, 5, 6, and these are my substituents. So this is the second carbon. So at second carbon we are having a methyl. At second carbon we are having a methyl, and this is the fifth carbon, and the fifth carbon we are having a formyl. So 5 formyl, 2 methyl, hex. This is the third carbon, and in the third carbon we are having a ene, hex 3 ene, and since it is an acid, so end it will be by oic acid. So clearly the option number 2 is correct option. Let's move on to the next question. Question number 12, this is again from chapter alkene. Here alkenes undergo electrophilic addition reaction. So basically we will see this particular reagent in the form of H plus and water. Now what will happen? This pi electrons will be protonated by this H plus, and you are going to get something like this. On this particular carbon there will be a carbocation, because the carbocation is more stable here, and here we are going to get a CH3 which is already there. Now you can see very clearly that outside the ring there is a plus charge, and this hints towards ring expansion. The 5-membered ring can be expanded to 6-membered ring, and how you are going to do that? You are going to do that in this particular manner. You are going to take this bond pair onto this carbon and when you will do this, this particular carbon will get a positive charge and this particular carbon will get a negative charge. Now this negatively charged carbon is going to attack at this carbocation, and that is how the ring expansion is going to take place. Now we will simply or directly we will draw a 6-membered ring, right, and in this 6-membered ring, say for example this particular carbon where there is the carbocation, let me number it as 1, and if that carbon is this number 1, now what does this carbon has? This carbon has a CH3, this carbon has a CH3. Now the plus is been removed because this pi electrons has attacked there. Now where is the plus? Here is the plus. Here is the plus. Now this carbon is adjacent to this carbon in the newly formed ring, so that makes it this carbon, and here we have the plus and a CH3 attached to it, a CH3 attached to it. Now we have a 3-degree carbocation which is stable, so the next thing will be the attack of the water molecule, which we haven't considered it. So this water molecule, the lone pair, will attack at this positive charge, and ultimately it will get deprotonated to get a OH at this position. So finally you are going to get here a OH, CH3 is already there, here will be an OH along with this CH3. Now as you can see from the options, which option is clearly stating this? I think option number 3, right. So here 2-3 things are there. One is that the electrophilic addition reaction of alkene, second is that ring expansion that is related to carbocation stability, and third is the nucleophilic attack of water, right. So next question is from again aldehyde chapter, and before getting into this reaction, let us see, this is an aldehyde or it may be a ketone also depending upon these valencies, which I am not interested currently. These are the lone pairs of this oxygen. Now what happens with this reagent? Now this particular fellow is an acid, it is a weak acid, so there will be an equilibrium between the dissociated and undissociated parts. Now this particular fellow will act as a nucleophile, because why? By looking at a carbonyl, you must know that they undergo nucleophilic addition reactions, right. So this is my nucleophile, this Cn minus will attack at this particular carbon, and this pi bond will be shifted over to this oxygen. As a result, you are going to get this particular species. Now this negatively charged oxygen is a base, and this is going to abstract this proton, and when this will abstract this proton, there will be a hydrogen, and these 2 valencies are there, whatever is there it is still there, and we have a Cn here. Now this is nothing but cyanohydrin, this is nothing but cyanohydrin. So this is a reaction of cyanohydrin. Now people, please understand that this attack is important. Now why it is attacking at this carbon? Because this carbon is having partial positive. This carbon is having partial positive. So that means what? If electron withdrawing groups are attached, this will increase the nucleophilicity of that particular carbon. So you see here, where do you have electron withdrawing groups? Now this is not electron withdrawing, this is not electron withdrawing, so we will reject option 4 and option 2. Now NO2 is of course electron withdrawing, NO2 is of course electron withdrawing, but at the ortho position there is steric hindrance. There is steric hindrance. Now because of this steric hindrance, the attack at this particular carbon will be difficult. Now on the contrary, here NO2 is placed at the para position, there is no steric hindrance at this carbon, at this particular carbon, so attack will be little bit more rapid. So the most reactive species will be option number 3, which makes the answer 3. The next question we have again from organic chemistry. Now here 2, 3, 4, 5 reactions are being asked. Now let me give you all the reactions in short. Now this is my starting substrate. These are the 2 lone pairs of that particular oxygen. We have a pi bond here and a methyl group there. Now you see we have HBr. Again HBr is an acid. So from here we are going to get H plus and Br minus. Now, whenever you have a H plus, what does H plus will look for? It is a positive entity, it will look for negative. So, C negative, negative means what? Electrons. So, lots of electrons are appearing here, so it will get protonated there. Now, once it is protonated there, it will be left with only one lone pair and it will bear a formal charge of +1 and this CH3 will be there. Now, oxygen with a positive formal charge is a very good leaving group, you might know this. Now, this Br minus will act like a nucleophile and it is going to attack here and this will leave and this will leave, and when it will leave, it will take back those electrons, and that is how oxygen is going to get rid of its plus charge, which oxygen does not want. So, this particular thing will get converted into a OH with two lone pairs, right, and here we are having a CH3 and now we are having a bromine here. Now, there is one more pi bond. Now, why I am focusing on that pi bond? Because it is written access, So, you can do another electrophilic addition there. Now, again this H plus will be coming from this HBr, and what will happen? This pi bond will get protonated. And once this is protonated, you are going to get a carbocation. Now, just tell me where you are going to have this carbocation. You are going to have this carbocation here, and the hydrogen will get attached to this particular carbon and other things intact. Now, why the carbocation is formed here? Because it is stable, it can undergo resonance with the ring, right. Now this Br minus, which is left after this H plus is come out. So, this Br minus will attack here, which is the nucleophile, and you are going to get a bromine attached at this position as well. Now, you can see and compare, they are talking about A. Now, what is A? A is a OH here, one bromine here, another bromine here. Yes, one bromine here, another bromine here. Yes, it is there. So, this is my correct, right. A is your this particular fellow, which is my option number 1, and since it is a single choice correct, I will not see the other options, but if you want to check, you can check the other options as well. Let us say for example, so here I will simply start from the A, which I have already obtained. Now, this A is this particular fellow, which you can see here. Right, this is my A. Now, we have alcoholic, not alcoholic, but we have a KOH here and we have a heat. Now, this is telling us that it is pointing towards elimination. Now, if I do an elimination here, then what is going to happen? I am going to get a pi bond here and I am going to get a pi bond here. That means I am talking about beta elimination, because this particular reagent is going to do beta elimination. So, we do not see any kind of pi bond in my option B, as you can see here, right. As you can see here, this is my option B, there is no pi bond. So, B is incorrect and A already we have found it out. And C, what is going to happen? If I am going to get pi bonds here, that means this will be my B. If I get a pi bond here and I get a pi bond here, this is my B, and if I do, this is actually ozonolysis, there might be a memory error, this is O3. So, ozonolysis. Now, if you are going to do an ozonolysis here, you are going to get a formaldehyde of this particular carbon as well as a aldehyde here as well as an aldehyde here. So, this particular thing will become an aldehyde. That means this has to be connected, Again, this particular carbon will also get converted into aldehyde, but see here they are saying it is still alcohol, so it is not correct. So, here the answer is A. So, next question. The next question here is very simple. Actually, it is from biomolecules. If you see glucose, let me draw the Fischer projection of glucose. This is the Fischer projection of glucose. Everybody knows this, right? Everybody knows this particular formula. Now, what is the key here, people, to understand? You need to understand what does this particular fellow does. Now, you have to know the reaction with this particular fellow, that is, I am taking an alcohol, alcohol reacts with them, that is what you have to know. Now, what is this AC2O? AC2O is basically something like this. Now, this oxygen pair is going to attack here, lone pair of the oxygen is going to attack here, this will shift back, but again it will be reformed because leaving group is there, right? That is how the reaction is going to take place. So, that means this particular fellow is going to react with the alcohol group, is going to react with the alcohol group. So, you have to count the number of alcohols that is present. Now, the first reagent that is given here is HNO3. Now, this HNO3, what it is going to do, it is going to oxidize this one into an acid and this one into an acid. Now, when they are oxidized into an acid, you are left with how many alcohols? 1, 2, 3, 4. So, this particular, how many moles will be required? 4 moles will be required, because this particular fellow reacts with alcohol. How many alcohols are there? 4 are there. So, this, how many moles will be required? 4 will be required. Now, in the second case, there is no HNO3, we are directly reacting with glucose, and in this particular case, we are having 5 OH, 1, 2, 3, 4 and 5. So, here how many moles will be required? 5 moles will be required. In the last case, we are having an H2Ni. H2Ni is basically what? It is a reducing agent. It is a reducing agent. So, it is going to reduce what? It is going to reduce this particular fellow. It is going to reduce this particular fellow into what? When aldehydes are reduced, you are going to get an alcohol. So, when you are going to put Ni and H2 onto this, then you are going to get an alcohol here. One alcohol is still here and other alcohols are intact. So, now you see how many OH group do you find? We find 6 OH groups. So, now how many AC2O molecules will be required for per molecule? 6, or for 1 mole it requires 6 moles. So, here the answer will be 6. So, 4, 5, 6 is what I need to see, and that is my option 3. Now, with this I wrap up this discussion. Hope you have liked it. Please do like and review. Thank you.